Okay, I guess I can start. We're actually expecting two more, but it's okay. I think maybe they might be coming later. Okay, now Yushen, since it's your first lesson with us, basically maybe just give you an overview. We actually are at part 4 of magnets already. Okay, have you learned magnets before in school? No, not yet. Okay. Some schools actually do it in primary 3 and some schools do it in primary 4. Okay, so if you have not done it, it's okay. I think we will still be going through in the second half of the year for revision. So that's fine. Okay, so what we do for science is a bit different from what we did for English. What we do for science is that we will, instead of rotating amongst the components, I think for science it's quite straightforward. There are only two components in your exam, either the MCQ questions, which is the multiple choice questions, or the open-ended questions. Okay, so in this case, we do not go through based on components, unlike what we did for English. We usually will go through chapters by chapters, okay, topics by topics. Yeah. So of course we cannot cater to all schools because sometimes different schools do different topics at different time of the year. Okay. But what we do is that we will definitely cover all topics that are required for you before you go for your end of year exam at the end of the year. Okay. So that's basically what we're doing. Now we are doing magnets number 4. Actually, Kelvin has been with me for quite some time. Okay. I think we've covered all the concepts as well as all the knowledge that you need for magnets, right? So what we do is we will use these concepts and this knowledge to apply it to questions later. Okay, so we will be going through questions later as well. Okay, but prior to this, I think we usually have some activities as well. Okay, so for this one, I think the house rules I don't have to go through lah, since Yushen, you were here with us just now for English as well. Okay, we will start off by watching a video first. Okay, so let me just share sound with you. Give me a while.
The Lighthouse Lab.
Oh, hey there. Have you seen one of these before? It's called a magnet and they're really fun to play with. A magnet is an object that can pull certain types of metal. It has magnetic force. Magnetic force is a non-contact force. It works over a distance. A magnet does not need to be touching the object it pulls. Check this out. Wow, did you see that? The magnet pulled the paper clips through the air. A magnet can attract objects that are made of magnetic materials. This means that the metal iron in these paper clips must be a magnetic material. Objects made of or containing iron will be attracted to magnets. Let's test it out. One of these objects is made of iron. Can you take a guess at which one? We have a coin, a key, a gold ring, and a nail. Let's test it out. Not the coin. The coin is made of copper and nickel metals. I guess they're not magnetic. Let's try the key. Nope, not the key. The key is made of aluminium. I guess that's not magnetic either. Let's try the gold ring. Nope, the gold ring isn't attracted to our magnet. Let's try the nail. Yes, the nail is attracted to the magnet. The nail is made of iron, which is a magnetic material. I wonder if magnets are attracted to other magnets. Let's test and see. A magnet has a north and a south pole. Let's try bringing the two north poles together and see what happens. Cool! Did you see that? The north poles repelled each other. I bet the same thing happens with the south poles. Let's test and see. Yes, the south poles also pushed each other away. Poles that are the same push each other away. Like poles repel. What do you think will happen when we place opposite poles of the magnets together? Just as I suspected, they attract. Opposite poles attract. I hope you had as much fun as I did today learning about magnets. See you next time!
Okay, so the video just now, I think, really showed us some experiments with regards to magnets. Prior to this, of course, the lessons which we've covered mainly were content, right? We covered the content, we covered some of the concepts that we need to know before applying. Okay, so we are going to go through the questions now. Same thing, we have 20 questions usually. So at midpoint, okay, at question 10, I'll give you a short break and then we'll go into game mode. Then after that, the next 10 questions, okay, before the reflection time. Okay, so the first question, Sabrina placed the following magnet into a container filled with iron safety pins. Which parts of the magnet would attract the most pins? Any volunteers? Anyone would like to try? Angela, you want to try, Angela? Okay. Have you done magnets in school?
Yes.
Yes, you did. Okay, great. Okay, so for this question, which part of the magnets would attract the most pins?
D and E.
D and E. Okay, can you explain why?
Because the end poles are the strongest part.
Yeah,
Oh.
correct. Very good. Okay, well done. So the concept, the underlying concept for this question is that the magnetic strength, okay, of a magnet is strongest at its poles. Okay. So basically, this is the underlying concept. Why this is the answer. Okay, the magnetic strength of a magnet is the strongest at its poles. And it just happened that D and E, if you can see clearly, D and E are actually the north and the south poles. Okay, this is a horseshoe magnet. So it has the poles at the bottom area here. So these two parts are the strongest actually. Yeah. Okay, now next question. Anthony made 4 electromagnets using the setup below. Which two of the following setup should he use to find out how the number? So whenever you see these 3 words, to find out, okay, basically they are telling you the aim of the experiment, right? So to find out how the number of batteries would affect the strength. So the number of batteries, maybe I'll just use another color. Okay, the number of batteries affect the strength of the electromagnet. So the number of batteries is actually your change variable. Okay, the strength of the electromagnets is actually your measured variable. Yeah. So in this case, we are changing, is the change variable. So we are changing the number of batteries. Okay. So actually we can use this and maybe this. Okay, we can use setup A and D. Why is it that we can use setup A and D? Because if you notice, the number of batteries is the change variable. One has 2 batteries, the other one has 3 batteries, okay? But the number of coils is the same. So we can use A and D for comparison. Okay, you just do need to take note that in any experiment, there should only be one change variable. The number of batteries is the change variable, so the number of coils of wire around the electromagnet must stay the same. Yes, Calvin, you have a question. Sorry, you were saying?
I just want to answer the question.
Oh, okay. Can you tell us what's the answer then?
C.
Answer is C. Yes. Okay. So I was just saying A and D is one possible setup that we can use, but okay, there's no such option if you realize there's no A and D in the options. Okay, so then you can use also B and C. Why B and C? Same reason. 3 and 2 batteries and the coils are the same. Okay, so very good, Kelvin. Answer is C. Okay. Kevin, can you please show your face? You just had a new haircut, right? So you should show your face. Very neat and tidy. Yes. Okay, now let's move on to question 3. Ping Ping had a bowl containing a mixture of 2 items. She successfully separated one item, leaving the other one behind. Okay, so this piece of information here, she separated one item using a bar magnet. So this item tells us that it must be, this phrase tells us that this item is magnetic because it can be attracted to a bar magnet. Okay, now we also left behind, okay, leaving the other item behind. So the other item is actually non-magnetic because if it's not able to be attracted by a metal a bar magnet, then it's probably non-magnetic. Okay. So out of all these 4 balls, which of these have a magnetic and a non-magnetic item or object? Anyone would like to try this question? Okay, let's go through one by one, yeah? Copper, magnetic or non-magnetic? Non-magnetic, yeah? Non-magnetic. What are the magnetic materials? What's the concept behind this? Magnetic materials. Very good. Steel, iron, nickel, cobalt. Basically, school is not cool. Okay. Steel, iron, nickel, cobalt. So copper is not a magnetic material. It's non-magnetic. Of course, erasers are made of rubber, so it's non-magnetic. Now for steel, magnetic. Iron, magnetic. Okay. Marbles, non-magnetic. Iron, magnetic. Marbles, non-magnetic. Erasers, non-magnetic. So the only setup with a magnetic and a non-magnetic object will be both C. So the answer is C. That means when they put a bar magnet here, okay, it will attract the iron nails, but you will leave behind the marbles. Marbles are usually made of glass, and glass is, of course, not a magnetic material. Are we okay with that? Yeah? Any questions so far? No? Okay. Now this one is easy. Which of the following cannot? These are basically testing you on applications of magnets. Which of the following cannot work without the use of magnetism?
A and B.
A and B, yes. Okay, so these more complicated appliances usually have magnets in them.